Hi, this is Vyshnavi from ACE department. Today we are going to discuss about new approach to Z transform through infinite computation. In this, the group members are Ragasudha, Venkata Naveen and Vyshnavi Reddy. First, we discuss about new methodology for dealing with infinite Z transform in Gross framework, some properties of the new Gross framework based Z transform. Z transform is an important mathematical tool to model sample data control system and other discrete data system. Z transform is defined as sum of infinity number of addends. Interesting to look for non-classical points through many current horizons. Recently proposed some properties are recently proposed by YD Sergiven. It allows to execute numerical computation easily. New approach, we obtain a very different type of Z transform of complex sequence. Regarding to applications of the Z transform, the most known ones are signal processing, digital control and geophysical, but widely used in all applied science. Z transform is simply power series represented discrete time series, and therefore it exists if the series converges. It is not necessary to use a particular numbers systems rather than another. Reserves a separate mention for the interesting and readable further axiometric approach proposed by Bennick and de Nassau called alpha theory. He develops a numerical computation system based on two fundamental atoms, the original natural numbers, one belongs to n, finite quantities, and new infinite unit called Grosjean for infinite and infinitism. Z transform is no longer unique but is replaced. Some classical well-known properties of the Z transform do not require appreciate corrections, other must be significant modifications. We will use n for the set of possible integers and n naught to indicate also zeros. We denote a sequence by a of n to the n or a of n, or sometimes simply by a of n. New methodology for dealing with infinite sequence sums and double infinite sums in the Grosjean framework. It knows how to develop computations and how to use the basic notions and properties. Extending set of natural numbers denoted by n bar, the extending set of integers as z bar is equals to n bar union to 0, union to minus n belongs to n bar, and the extended set of non-negative obviously as n naught bar is equals to n bar union to 0. R bar denoted the extended set of real numbers. Extended set of complex numbers C bar is equals to R bar plus I R bar. Let A of n be a sequence of complex numbers. The double-ended series summation plus infinity to n is equals to minus infinity A of n converges to A belongs to C if three conditions is possible. Summation plus infinity to n is equals to 0. A of n converges to some beta belongs to C. Summation plus infinity n is equals to 1. A of minus n converges to some gamma is equals to C, and beta plus gamma is equals to alpha. Given m comma n belongs to n bar, infinity or finite, and n belongs to C bar, we can say that the summation n to n is equals to minus m and is equal to a belongs to C bar if by definition. Summation n is equals to 0 and equal to some beta belongs to C bar. Summation m n is equals to 1, a minus n is equals to some gamma is equals to C bar, and beta plus gamma is equals to alpha.
Transform in the Grossman framework. The Z transform is the fundamental tool to progress signals. It converts a discrete time signals, which is a sequence of real or complex number, into a complex frequency domain representation. The Z transform of sequence x of k infinity, where k is equal to minus infinity of complex numbers, denoted by z of x of k or x of z, is defined as the following series. Z of x of k is equal to x of z summation, that is equal to summation infinity, where k is equal to minus infinity, x of k into z minus k in the complex variable z, the z transform of the exponential sequence in the new setting. In this and the next subsections, we'll consider some simple sequence that represent fundamental discrete time function in signal theory, and we will determine and study the z transform arising from them through the lens of gross 1. Let us take the sequence x of k is equal to 2 minus k, where k belongs to z. A pure mathematician would refer to the sequence x of k is equal to k, where k belongs to z, simple as the identity map on the integers. Instead, signal theory specialists often call x of k and some similar others the unit ramp sequence, the classic Z transform of x of k yields the complex function, that is x of z is equal to summation infinity, where k is equal to minus infinity, k into z minus k is equal to summation minus 1, k is equal to minus infinity, k is z minus k plus summation infinity where k is equal to 0 and k is it k into z is minus k. Properties of new Gaussian based Z transform. Time shifting. Let x of k be any complex sequence and I belongs to Z, a fixed integer. Posing y of k is equal to x of k minus I, we have y of z minus m n is equal to z minus I, that into x of z minus m minus I and n minus I. For all m and n belongs to n of n with minus m is less or greater than less or equal to 1, I less or equal to n, and all z belongs to c of minus 0. Time reversal. Let x of k be the k be any complex sequence and pose y of k is equal to x of minus k. Then y of z minus m n is equal to x of minus 1 minus n m for all m and n are belongs to n. Change of scale. Let x of k be a complex sequence, a any non-zero element of C, and pose y of k is equal to a into k into x of k, then y of z minus m n is equal to x into a minus 1 into z minus m n for all m and n belongs to n. Differentiation. Let x of k be a complex sequence and y of k is equal to k of x of k into x of k. Then y of z minus uh, minus m n is equal to minus z of d of x z minus m n, where dz for all m and n belongs to n. Time difference. Let x of k be a complex sequence and y of k is equal to x of k minus 1. Then y of z minus m n is equal to minus 1 minus z minus 1 into x of z minus m n minus x minus m minus 1 zm plus x of n z minus n minus 1 for all m and n belongs to n. Time accumulation. Let m and n belongs to n and x of k be a complex sequence if we pose y of k is equal to kh, that is equal to minus m x of h for all minus m lesser or equal to k is less or equal to n, then y of z minus m n is equal to n plus m, h is equal to 0, z minus h x of z minus m n minus h for all z belongs to c. Convolution. Let x1 of k into k comma x2 of k be two complex sequence over z, and let m and n belongs to n. If we set y of k is equal to x of 1 into minus m and n into 2 into k, for every k belongs to z with minus 2m lesser or equal to k, and k is lesser or equal to 2n, and then y of z minus 2m 2n is equal to x of 1 z minus m n into x of 2 into z minus m and n.
Myself, Venkata Naveen, today discuss about in conclusion the indispensable uses of a symbol infinity by classical mathematical analysis is very often classes a process of efficiently high equate when one delay with expression involving numbers which tend to become rapidly infinite and infinitesimally like to sequence of a series. In this show that the recently prosed based on methodology can be using applied to a compare the results of a double infinity sum of to study the transfers of a sequence in complex numbers as well as we remark the important fact released by investigation and constantly not a single function but a many different functions mm, in the end of the summaries and represented by z transfers in itself. Lastly, we have show some classical properties and z transfer will beginning responsible in substance in the new context, new more or less changes in depending on the cases. This is the reference. Thank you.